we're going to look at 3 more substitution questions. So our first one, we have a quotient, and so we want to decide what we're going to let be u. And I need u to be the thing, one, that I can integrate. So the top or the bottom could be u in that case. But also I want u to be the higher power so that its derivative is there. So for example, letting u be the bottom thing, the derivative of a cubic is a quadratic, so that's a better strategy. So we're going to let u equal, and you want to make sure to let u equal the whole bottom because you know how to integrate 1 over u, right? So think of this as like the ax plus b, only there's something else in there. Okay, and then we're going to ignore the question and find the derivative with respect to x. Okay, and then we're going to put it all in terms of x. And then we're going to go and see, does that match up? Nope, I'm off by a factor of 3, but I could just divide that out, bring it to the other side, and then I have a good substitution. So again, my u and my du is going to be replaced. Okay, so all of this gives me this new integral of 1 over u times 1/3 du. And I'm going to bring, that 1/3 out front. And that equals ln 1/3, absolute value of u plus c. And then I just want to resub that back in terms of x. And my final answer is 1/3 ln absolute value of x cubed plus 3x squared plus 12 plus c. Okay. So again, you want to let u be the whole thing inside one of those 5 rules. So this was in the denominator of a 1 over x. Okay, our next question doesn't look like a substitution question, but it is because we don't know any derivative that the answer is tan x. So we don't have a rule for this. But I could rewrite the question as sine x over cos x. Oops, getting carried away with my du's there. Okay, and then I have to decide which one of those I'm going to let be u. So the thing is that both of them are there, the derivative of both are there. But if I let the top be u, then this is going to be, like I'm going to be left with 1 over cos x dx, and that won't be the derivative. So I'm going to let u, you could just try that and you'll see what I mean. Let u equal cos x, and then ignore the question, and find du dx. The derivative of cos is minus sine x. And then I'm going to bring over the dx. And I don't have a negative in my question, so I'll bring it over here with the du. Okay, and then when I put this all together, I get 1 over u and a negative, which I'm going to bring out front, otherwise it might look like a subtraction. And then this is really easy to solve. And then I'm going to resubstitute back in terms of x. So the antiderivative of tan x is minus ln absolute value cos x plus c. Okay, so I'm just going to show you quickly what I mean if I had let u equal sine x. What would have happened? I would have got that du dx is equal to cos x, and then du is equal to cos x dx. But in the question, what I really have is sine x times 1 over cos x dx. So you can see, even though the sine x is there, this doesn't match this. So I can't replace it with du. So this doesn't work. So if you pick the wrong thing and it doesn't work, then you got to go back and pick a different u. Okay, if you have questions about that, just stop in and see me. All right, one more question here. So we want to let u be the x squared, because solving e to the u is something we can do, and the derivative of a quadratic is linear, and that's sitting there. So let u equal x squared, ignore the question, du dx is equal to 2x, so du is equal to 2x dx. Okay, so you have a 3x dx there, but you can just leave the 3 and you just need to replace the x dx, because the 3 is not in terms of x or u, so it won't make a difference. So I'm going to make this 1/2, and then I get e to the u, the 3 is still there, and then I have 1/2 du. So do you see how you can just, a constant won't matter, it can stay. And then I'm going to pull those constants out front because that's easier to deal with them. And then this just equals 3/2 e to the u plus c. So this is 3 over 2 e to the x squared plus c. So you want to remember at the end to replace it back and answer the question. So all this is just the work that you're doing to answer the question.